Hey everyone, this is number one from the 2018 FRQ. This is the calculator section. And we're looking at part B today, but I left part A because it's related. So this question gave us that people are entering a line for an escalator at a rate modeled by the function r, given by r of t equals 44 times t over 100 to the third times 1 minus t over 300 to the seventh, and that is for 0 to 300. And then the rate goes to 0 for t greater than 300. R of t is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. And there are 20 people in line at time t equals 0. All right, so my first question for you is, which function is the rate in? And that would be the r of t function. Which function is the rate out? And that would be 0.7. And the last question is, at time t equals 0, how many people are in line? And that is 20. So I did highlight these, that they're giving us the rate people are entering the line, the rate people are exiting the line, and then how many people are at time 0. We had talked about these in class, kind of these classic rate in, rate out questions where there's people in line at the beginning, there's people coming in the line, there's people leaving the line, etc. So it says for part B, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? Okay, so the first thing is, you know that you have 20 people in line at time 0. So there's 20 people there already. So we're trying to figure out how many people are in line at time 300. We're going to start with those 20 people. The next question is, if you know the rate that people are getting in line, how are you going to actually find how many people are getting in line? So you have the rate people are getting in line. How do you find how many actual people are getting in line? And the answer is to take the antiderivative. So remember, if you're given the rate people are entering the line, taking the antiderivative is going to give you the number of people who have entered the line. Who have entered the line. When you take a derivative, then it becomes a rate of change of people entering the line. Antiderivative gives you that total accumulation, or just total number of people who have entered the line. So the people entering the line are getting a plus sign because they're getting in line, and we're going 0 to 300 r of t. The last part of this is that we have people that are leaving the line, right? We have people there at the beginning, that's our 20. We have people getting in line, and we have people leaving the line. So the next question is that they gave us the rate that people are leaving the line. And so my question to you is, if you know the rate that people are leaving the line, how are you going to find the total number of people that are leaving the line? And again, that would be the antiderivative. And I have a subtraction sign because they are leaving the line, right? That's our rate out. So I could go back to the same diagram and just change it, rate that people leave the line. The antiderivative would give us the total number of people who have left the line, whereas the derivative brings it back to the rate of change people are leaving. Antiderivative is that total accumulation, or just total number of people that have left the line. So then that would be a minus sign. The rate that people are leaving the line is 0.7. and that's going to be dt 0 to 300. I'm also realizing I've missed the dt there as well. So this is going to be the expression that gives you the number of people in line at 300. You have 20 people in line at the beginning. You're adding the people that are coming in, and you're getting that by taking the rate they're coming in and taking the antiderivative to get the total number of people that are getting in line. The minus sign, the number of people that are leaving, taking the rate that they're leaving and getting the antiderivative to just get the total number of people that have left. And this is the calculator section. So I do have this typed in already, and I'm going to go hit enter and show you this. So I started with the 20 people that were in line already. That's there at the beginning. Adding 0 to 300, this is the R of t function. Those are x values, how I'm typing them in the calculator, and then that would be a dx at the end. And then finally, the minus sign. Math 9 to get the integral, 0 to 300, and then you have your 0.7 dx, and that gives you an answer of 80. This is being really slow right now, but there we go, answer of 80. Okay, so I'm gonna write equals 80 and put a box around this. Okay, so two things. Here's the rubric. You can see the 20, you can see the plus sign 0 to 300 R of t minus the 0.7. So they actually wrote it as one integral where we had it as 2. Either way is fine. You can see that they got the answer of 80. So they got a point for just thinking about the rate out. I think if they could see that 0.7 in there somewhere, and then a point for the answer of 80. Again, you do not need to write that sentence, but you can. It's not a bad sentence. According to the model, 80 people are in line at time t equals 300. The very last thing I wanted to say is if you watched part A of this, I'm going to write our expression that we were using. 0 to 300 R of t dt minus 0 to 300 0.7 dt. So if you watched part A of this question, part A was figuring this out. So you might have looked at part B and just automatically known from part A that that integral was going to be 270 and then went from there. And that's totally fine. So you would have had the 20 that we started with, the 270 who came in line that we figured out in part A, and then you had to subtract the people that were leaving. So that would have been fine to kind of just start with writing that expression and using the answer from part A. All right, that is it.